Hi friends, I have come here to take the classes on GATE concepts as well as CETA PG concepts. What is GATE? A GATE is an India level examination which is the very toughest examination of all over India for engineers. And what is CETA PG? CETA PG is the examination conducted by Tamil Nadu for getting into engineering colleges for M.Tech or ME or M.Plan or M.Arch. So for all these things we should know a bit of we should have a knowledge about the engineer, not a little bit, we should have lot of knowledge in engineering. So I have completed B in computer science and engineering. So I'll be taking classes on computer science only. And this gate to crack this gate examination, we should have a knowledge completely from the starting to the end. Only then, of course, we can score a very good score. So a very good score is needed to get into IITs or NITs or triple ITs or any other very reputed institution. Also, GATE is used for getting into Maharatna and Navaratna companies. Now let us get into the topic. Firstly, let me take the concept on computer networks. So in upcoming slides also, I will be presenting about the computer networks only. Upcoming slides in the sense, upcoming presentations also, I will be presenting about computer networks only. And after this playlist, I will be going to the next playlist for computer organization and architecture. So this picture itself shows the LAN cable. Let me tell you what is LAN later on. And let me go. This cable. I think you will be familiar with the word LAN cable, but you might not be knowing what is LAN actually. But this LAN cable, this connecting it to your computer, everything you might have done already. Let me get into the concept. So let us consider that each of the computers are present in a separate location. Five computers are there. They have been placed in five separate locations. And these computers, when they have to communicate with each other, how should they be connected? With the help of wires. So there are different types of wires that are being used for different distances, and for each of the distances different types of wires are being used. We shall go through them slowly. And now let us come to the introduction alone. So this is about the hardware. Apart from these wires, you need a lot of uh, things like antenna. And in the case before antennas, and that is the antennas are used to communicate with the satellites, and these kinds of hardwares are also being used in the computer networks. Now let us go to the software part. So what software is needed for this computer networks? It is network operating system. So you might have been familiar with the operating systems, the like Windows OS or Unix or Linux. All these are operating systems. Why do we use operating systems? Because we have to come, that is this computer software helps in communicating with the computer. And this communication happens also between the mouse, printer, and keyboard, all kinds of these hardwares. And if one computer has to communicate with the other computer, this network operating system is used. I've given in the list a lot of network operating systems. They are Microsoft Windows Server, Unix and Linux, Cisco iOS, and Juniper Junos. This Microsoft Windows Server is different from Microsoft Office. I mean Microsoft Windows, because for Windows means it is for personal computers, and these Microsoft Windows Server is for servers. These servers I'll tell you what is meant by a server later on. These are large storage areas and they are able to communicate with other all of the machines. They'll be able to communicate with the other machines. So they are known as servers. Unix and Linux were also designed for servers only, and later they have been made use in the case of uh, normal operating systems. And Cisco iOS, Cisco itself is for communication, a communication company, and it has released its Cisco iOS. Juniper Junos, it is also like Cisco. Juniper is also a communication company, and it has also released its network operating systems, namely the Junos. So here I have given two terms, networks and bridges. Let me explain what is a routers and bridges. Let me explain what is meant by a router, and we'll go to the topics, other topics. Bridges will be dealt later on. What is meant by a router? So for example, here you have five different locations, and each location has three computers. So these three computers are connected with a network operating system, and when each of these different locations have to connect together, these routers are used. And subnets, there is one more topic called subnet. So don't get worried by hearing all these kinds of different keywords. These are as normal as that. So what is meant by subnet? For example, here in the center you have three computers. These three computers act as a subnet because they can connect to all of the other four areas. So they act as a subnet, and the computers inside these act as routers. That's as normal as that. A subnet is the area which is in the center and is able to connect with all of the other computers, and and the router is the computers which help in finding the routes. For example, now we'll go on and I'll tell you this distributed systems. What is meant by a distributed system? Here we have seen the computer network of networks before, and here what is the difference between a distributed system and a network, computer network? Okay, I'll tell you with this example. Here in all of the five areas we have different computers, right? When each of the computer is able to give signals or act as of its own, it is known of its own without the intervention of any user, then it is known as a distributed system. For example, clouds act as distributed systems. In clouds, each of the computer will able to act of its own. But in the case of a computer network, you have to, if you are in need of sending a message from one computer to the other, you have to open and create a network, and you have to just pass the message. Whereas in the case of distributed systems, these clouds act as its own. What is meant by cloud? Let us go on next. This is just an introduction. In this distributed system, I have given a number of operating systems: Solaris, OSF1, Micros, Unix and Linux. So Unix and Linux, see how useful it is. They have created this, and it is also a free open source software that is of very good importance. Because of its open source nature, we can use it with our own convenience. So that much level of freeness has been given to us by Unix and Linux. It is supporting both computer networks as well as the distributed systems. And micros, okay, it is a Microsoft's operating system, distributed systems operating system. So Solaris as well as OSF one or other operating systems. Okay, now let us see some of the technologies that are being used in the case of different companies. So here let us see BSNL as well as SBI. BSNL uses Apache and Tomcat server, and here it is this Apache and Tomcat server are not network operating systems, but they are a technology that help in storing information. And SBI's Megdut, it is a private cloud, so they are much advanced. They use clouds. They connect about 15,000 cloud computing computers. So they are of that much importance and need. Now, local area network. Now let us come to this. What is meant by local area network? So there are three kinds of networks: local area network, metropolitan area network, wide area network, and these three are the different kinds of networks. Apart from them, inter networks are also there. Firstly, let us classify these three. This local area network is of very small distance, a building or something like that, a company's building or something like that. So it can cover up to 100 megabits per second. Here, this megabits per second, and that it should be given a note. What is mega? That is megabits per second. It's not megabytes, it is megabits per second. How many bits could be transferred, and that is represented as megabits per second. Through these wires, how much of data could be sent at a time? At a time, one bit, either one bit or in some cases 1 byte, that is of parallel. Parallelly 8 bits can be traveling, or 16 bits can also be traveling, or only 1 bit can also be traveling. That is the way in which it is designed. And bounded size, so as I told you already, it will cover only one building, and this building, in this lot of building, or even small area, a small area that is within a compute, that is within a company. So this is how it is designed. So here this is called as a LAN cable, as I told you already. And what is this arbitration that I have given you here? What is meant by an arbitration? For example, as I told you previously, it could be found in case of this token ring, or token ring here IEEE 802.5. It is the IEEE standard. So when all the computers are connected in a ring, it is called as token ring, and when they are connected in a bus, it is called as bus topology. And here in that case, it is also called as IEEE 802.3. Here in this, get tone, what they have given us, get tone, it is getting its, here that is the computer 6, it is getting its turn, and when it is getting its turn, it will be able to send the data. So here here comes the strategy. Firstly, when a number of computers are connected together in a LAN like this, each of the computers should get its turn, and it is known as round robin scheduling. As you have studied in the case of as you have studied in the case of uh, these operating systems. So here, as in the case of round robin scheduling, here also round robin is used. Each of the computer gets its turn, and it is allotted a time slot. In its time slot, if it is able to send the data, it is not able, it is ready to send the data, it will send, or else it will be waiting as such. So this is a waste of time, right? When each of the so let me show you, it is a waste of time when each of the there is this round robin. When it is used, when a particular computer is not ready to send a data, but the time is allotted to that computer, then what shall happen? It will be remaining in that state and pulling the network's traffic to it. So it will not be ready to send the data also. So the bandwidth is getting wasted. So a bandwidth is how much of data could be sent at a time. So the entire bandwidth is getting wasted for this one computer. So this is known as round robin and static allocation. Static. This is known as static. Each of the thing is happening statically. So this this is not of very good. It's not a very good strategy. Look at this dynamic allocation. It could happen centralized also. So here, as I told you, the uh, router and all. So here a subnet is there in the center. It is having four routers, and all others are other so here S1, S2, S3, S4 and S5. All other networks are other networks which are present inside the entire network itself. That is internet itself, only five networks are there, and they are connected by the subnets. I mean, by the router R1, R2, R3 and R4. So here, dynamic allocation, here it is centralized. Here everything is centralized. All the networks that is centralized in the sense, if it has to send one subnet has to send data to the other network, it should has to pass it to the subnet. The subnet will send it to the other network. So it is centralized. So here, dynamic allocation itself, here it is centralized in the first case. So whenever one computer has to send the data to the other, it should pass it to the central computer in the star topology, and then it will be sending it to the particular computer. But what is meant by decentralized? Here, in each of the, so here, as I told you previously, each of the LAN has its each of the LAN is, it is connected by wires. Of course, here when you see all are connected, you might ask the question, all are connected by wires only, right? Yes, all are connected by wires only. But LAN means a small area. When it goes beyond that, it is called as WAN, wide area, or MAN. It should given in that kind of name. So here in the LAN, so each of the small stars present in the decentralized are called as LANs, and the centralized and when in the case of centralized, only one computer or one subnet is there. Here each of the thing acts as its own. If everything will be sending to its own central computer, and that computer will pass it to the other computer. So this is decentralized. Then, ma'am, what is the difference between decentralized and distributed? Okay. In decentralized, of course, all the computers are not acting separately. All the computers will be passing the data to its own central computer. But in the case of distributed, as I showed you in the last part, it is getting black. That is, it is not being shown because of my face. So look at that. That is distributed. In that, each and every computer acts as of its own. So that is known as distributed. So man, so this much time we have been discussing about land. Now let us come to man, metropolitan area network. Here three cities are considered. Between it is between cities, so it is of course to a bigger area. So each of the different cities are there, and these cities are interconnected, and this is known as a man metropolitan area network. DQDB. DQDB is distributed queue dual bus. What is distributed queue dual bus? And if you see at the picture in the right hand side, three computers are there, and towards the left one long wire is passing, towards the right one long wire is passing. One wire is for the requests and the other wire is for the transmissions. So this way it is performing the actions. This is also known as IEEE 802.6. So here the things that you should keep in the mind is, what is IEEE 802.3? Yes, IEEE 802.3 is the, yes, yes, it is a bus. It is a bus. What is meant by IEEE 802.5? It is token ring. And what is meant by IEEE 802.6? Distributed queue dual bus. Then comes the wide area network. Wide area network is between countries, and it may also between continents. So circuits, and that is the common terms that you should be keeping in your mind is circuits or channels or trunks. All these three are the same. Circuits means it is the thing. It is the circuit, that is wires and the computers that are being connected. Channels, the channels are also the same way. That is, it is passing through this channel. You cannot tell it as it is passing through this circuit in the case of data communications. You could tell it as it is passing through this channel. And trunks are also the routers and the other information passing elements that are present. And the next thing that you should know is packet switching nodes, intermediate systems, and data switching exchanges. So the routers, so these are the things that is being explained. The next one is point to point, store and forward, packet switched. So these three things are the same. Point to point, they say between each and every computer host, each and every host. And store and forward, what is meant by store and forward? It stores the information which is passed to it, and later on it passes it to the next computer. So it is store and forward. Packet switched, it is switched from one network to the other network, one LAN to the other LAN through these routers. Okay, this person, Guglielmo Marconi. Guglielmo Marconi. He started the wireless networks. What he did is he just transmitted bits from the sea to the shore, from the sea to the shore. using these antennas and all. He worked and he just transmitted the bits from the seas to the shore. So this is how this person started telling about the wireless networks. So here now, what is meant by wireless LAN, ma'am? Here, look at this. Here, inside the this is not a room and all. It is an airplane. Inside this airplane, you can communicate with the airplane nowadays, right? So here it should communicate. If it is able to communicate, before it was like long wires. It is all, even now it is being used in that way only. Long wires, lands are being connected through the inside, through the sitting areas and all, and where you can sit and open the computers and you can work, you can connect the LANs. And how these, through these LANs, it just goes to the switch, and from there the packet switching area, from there, which is present inside the backside of the airplane, from there it is just passed on to the wireless network. So this is how it is happening. This is a wireless LAN. So I think this video is helpful to you. If you like the video, subscribe to my channel and get more uses through the videos that I put in this channel, and comment on this video and about the pros and cons of this video. I'll be able to change and I'll be able to give you more good stuff. And if you like it, click on the bell icon. Thank you.